Level methods. We're going to look at exercise 17F, question 3 and question 4. Okay, so for each of the following functions, state the values for x where there's discontinuity, okay, which means that, if we have two graphs, they don't, there's a gap in between, okay? Either the gap's like this or like this. Okay, so there's like a actual jump. Okay, so those are known as discontinuities. I literally need to lift my pencil to draw the graph completely. Okay, so how do we determine this without having to draw the graph? Okay, you just look at where they potentially connect or not connect. So for here, it's 0, 1, at -1 at 0. And you check this by doing a test, okay? So you need to make sure the limit from the left and the limit from the right are the same. And you also need to find, so you just determine whether the limit from the left and from the right are the same. So, and the value exists, okay? So first of all, we need to check whether the value exists. So we're interested in 0. So I'm just going to find f of 0. F of 0 happens to equal, well, can you see that there's a little equal sign there? So it includes 0 for this graph. So I'm going to sub in 0 for that graph. So 3 times 0 is just 0. Okay, so that point exists. Okay, so first of all, the point must exist, because if the point didn't exist to begin with, then we're sure that it's discontinuous. Okay, there's a discontinuity at that particular, wherever the point does not exist. Okay, now we want to check whether the left-hand limit equals the right-hand limit. Okay, so if I'm approaching from the left, the equation which is from the left would be here, because x is less than 0, okay? And the one from the right would be there. So I'm going to find the limit as x approaches 0 from the left, and it's denoted by x minus of f of x. So when I sub in 0 from the left, I get -2 times 0 plus 2, so that equals 2. Okay. If I find the limit as x approaches 0 from the right, x plus of f of x, I'm looking at this equation. So 3 times 0 is just 0. As you can see, although this agrees with that, the 2 does not agree with the 0 here. Okay, so these don't agree. So therefore, there's a discontinuity when x equals 0. Okay. For b, we do the same thing. I need to find f of 1, because that's where possibly the discontinuity occurs. So let's find the value of 1. Now, where does it equal? It equals here, so we're using this equation. So f of 1 is 1 squared plus 2, which is 3. Okay, I'm going to find the limit as x approaches 1 from the left. So from the left, we're looking at this equation here, -2 times 1 plus 1, that equals -1, okay? And from the right, limit as x approaches 1 from the right-hand side. I'm using this equation here. So sub that in. 1 plus 2 equals 3. Okay. Can you see that no matter what I choose, 1 plus 2 equals 3, although this and this agree, this doesn't, okay? So meaning that there must be a discontinuity at x equals 1, okay? Now for C, you have to do it two ways, okay? So first of all, you're trying to find if there's a discontinuity at x equals 1. So we want to find -1, sorry. If I want to find f -1, where does it equal -1? It equals -1 here. So I'll just sub that in. So -1 times x would be +1, because you've got negative at the front. So negative of -1 is +1. And then from the right, h approaches 0. The limit of x approaches -1 from the right, from the left, sorry, from the left, is when it equals, when I sub into the first equation again. So that's +1. Limit as x approaches 1 from the left, -1 from the left. I use the second equation, -1 squared equals +1. Now, there's something interesting here, okay? Can you see all three agree? Okay, so there's no discontinuity. So it's continuous at x equals -1, okay? And we want to check for the value of 0. Is it discontinuous or continuous at 0? Okay, so go through some process. F of 0 equals, okay, what does it equal 0? It equals 0 for this equation. So we'll sub that in. -3 times 0 plus 1. So that's 1. We want to find limit from the left and from the right of 0. So limit of x approaches 0 minus of f of x would equal, so from the right would be this equation, because this is more left from that, looking at the domain. This is from -1 to 0, and this is from 0 onwards. Okay, so this must be the equation from the left. So if I sub it in, I get -1 squared, not -1, sorry, 0 squared. Looking at the other question, 0 squared, so that's 0, and limit as x approaches from the right. So I'm looking at too many drawings there. I'm looking at this equation. So 83 times 0 plus 1 equals 1. So again, while these agree, that doesn't agree. Okay, so therefore there's a discontinuity. There's a discontinuity at x equals 0. Okay, so all three must agree for it to be no discontinuity. Okay, for 4, the rule of a particular which values is discontinuous. Okay, so again, for this one, we've got possible discontinuous at either 1 or 7. So we've got to do them separately. So we'll do the 1 first. So f of 1 is equal to, so which value do we choose? It equals 1 on the second equation, so you have to sub that in. 1 minus 4 squared minus 9. That's minus 3 squared, which is 9 minus 9, which is 0. Okay. Let's check the limit. So limit as x approaches 1 from the right hand side, left hand side, sorry. Left hand side is when it's less than 1, so that's left to the left. Well, we know that the limit as x approaches -1 of 2 is just 2, okay? And the limit of x approaches 1 to the right of f of x, so which equation do we put for the right? Would be this one. Would be, so if I sub in 1, I get 1 minus 4 squared minus 9, which equals 0. We just worked it out. So that's the same, but that's not the same. So at x equals 1, there's a discontinuity. Okay, and then finally we'll do the last one. So we're trying to find out if there's a discontinuity at 7. So f of 7 equals 7 minus 4 squared minus 9. 7 minus 4 is 3. 3 squared minus 9. 9 minus 9 is 0. Okay. Limit as x approaches 7 from the left of f of x. So on the left, which one's the left? This one's the left, okay, because that's from 1 to 7, and that's from 7 onwards. So again, you just go 7 minus 4 squared minus 9. Again, you get 0. And then the limit, over here, limit as x approaches 7 to the left, from the right, sorry, 7 plus. So you're following this equation, because that's the equation to the left of f of x, so x minus 7. So we got 7 minus 7 equals 0. As you can see, all three agree, so therefore it's continuous at x equals 7. Okay, so there's only, out of all those examples, there's only two cases where it's continuous. So hopefully that gives you an idea of how to do it. So those are the tests you do. So you basically find f of the value, okay, of interest, and then you find the left-hand limit and right-hand limit. Everything has to agree in order for it to be continuous. Otherwise, it's discontinuous.